If you're just joining, we'll get started in just a couple of minutes. All right, welcome everybody. My name is Lucian Fogoros. I'm the co-founder of IIoT World, and our other co-founder, Karolina Rudinsky, is monitoring the channels. Gregory Orloff will be our moderator for today. So if you have questions, feel free to submit them in the chat, in the Q&A, or via the social channels using the hashtag #IIoTROI. So Gregory, welcome.
Thank you, Lucian. Good morning, good afternoon, and good evening, everyone. For those of you joining us the first time, please allow me to offer a little background on our organization. IIoT World is a digital media publication that covers the economic and technological implications of the transformation taking place as industrial IoT proliferates throughout the enterprise. IIoT World combines journalistic coverage with data analysis to expose the stories, players, trends, and innovations that shape the IIoT. IIoT World was recently ranked by Kcore Analytics as the #1 global influencer on several topics that include industrial IoT, smart manufacturing, ICS security, SCADA, predictive analytics, and predictive maintenance. Our mission is to help companies create a culture of innovation and connect the smarts, industrial technology, manufacturing, sensors, and CXO decision makers. Today, we have an exciting panel that representation from the Industrial Internet Consortium, Siemens, and Altavia Consulting, LLC. In this 90-minute virtual conference, our speakers attempt to inspire manufacturers by showing approaches and perspectives that they might embrace to achieve impact at scale. In other words, our speakers will explain using real examples how to make money using IIoT. It's always interesting to learn how others have done it, so let's jump right into our first session. The state of the market, and our first speaker is Stephen Meller, CTO, Industrial Internet Consortium. Like many revolutions, the exact date of the initiation of what we call the industrial internet is not exact, but many tie it to a paper by two economists back in 2012. Their top-down estimate of the effect on the industrial internet on the market is huge, but their bottom-up estimate of a 1% improvement from asset efficiency was borne out in half the time. This presentation outlines the possibilities for the market, positions the current state of the market, outlines the next wave, which is already partially upon us, and looks to the future. Remember that the URL was invented 40 years ago, and Sir Tim Berners-Lee never imagined typing this up on a train with his ticket, which he read on his phone. So a little bit about Stephen. He is the Chief Technology Officer for the Industrial Internet Consortium, where he directs the standards requirements and technology and security priorities for the industrial internet. In that role, he coordinates the activities of the several engineering, architecture, security, and testbed working groups and teams. He also co-chairs the definitions, taxonomy, and reference architecture work groups and the use cases work group for the NIST CPS PWG. And let me translate that acronym for you. That's the National Institute for Standards and Technology's Cyber Physical System Public Working Group. Stephen is a well-known technology consultant on methods for the construction of real-time and embedded systems, a signatory to the Agile Manifesto, an adjunct professor at the Australian National University in Canberra, ACT, Australia. Stephen is the author of Structured Development for Real-Time Systems, Object Life Cycles, Executable UML, and MDA Distilled. Until recently, he was chief scientist of the embedded software division at Mentor Graphics and founder and past president of Project Technology, Inc. before its acquisition. He participated in multiple UML modeling-related activities at the Object Management Group, OMG, and was a member of the OMG Architecture Board, which is the final technology gateway for all OMG standards. Stephen was the chairman of the advisory board to IEEE software for 10 years and a two-time guest editor of the magazine, most recently for an issue on model-driven development. Stephen, the floor is yours.
Thank you very much, Greg. I need to shorten my bio, I can tell. I also need to check my numbers. The URL was invented in '89, so 8 and 3 is 11, so it's actually 30 years, not 40 years. But that's my fault, because that's what I wrote into the description of the presentation. But in any event, good day, everybody. Let's get straight to business, because we do, after all, have a limited amount of time. What I'm going to be talking about today is the state of the market. And as Greg indicated, I'm the CTO of the Industrial Internet Consortium, now with OpenFog. We joined forces with them at the end of January this year, and we're working together on fog and edge computing as a part, of course, of the overall consortium's agenda. And that is to accelerate the development of the industrial internet. So our first step then is to try to understand what that means. So I'd like to begin by looking at comparing the industrial and the consumer Internet of Things. First thing to understand is that the technology drivers are pretty much the same. We have small, cheap sensors and actuators. We have low-cost processing and data storage. We have smarter and smarter devices as time goes on. That's why we need to chat a little bit about edge and fog, although not in this presentation. And finally, of course, we have ubiquitous connectivity. I find it disturbing when I can't get through to my Wi-Fi system. There's a wonderful re-rendition of Maslow's hierarchy of needs that has battery at the bottom, Wi-Fi next, food and shelter and above that, and then all the way up, of course, to self-actualization. But we now have pretty close to ubiquitous connectivity. But the business drivers are quite different. For the consumer, the quality needs to be good enough. And that, of course, is not true in the industrial space. It needs to be quite high. Security needs, everybody talks about security, and hacks into Yahoo accounts and that kind of thing get people very excited. But primarily, I believe that that's a reaction to privacy concerns. And of course, people often use the same password to access financial accounts. And that's pretty serious. But compared to, for example, hacking into a chemical plant and dropping a load of toxic chemicals into the river, really it's not that big a deal, he said, hoping he hasn't been hacked in the last 5 minutes. The other thing, of course, with consumer IoT, that's kind of Fitbit-y kind of stuff, is that it's cost sensitive. We can pay a fairly good chunk of change for a phone, but that's about as far as it goes. We're not going to spend a whole lot more for some of these gadgets that we carry around connected to the internet. And again, that's entirely different in industry. For industry, we care about quality of service. We need robust security, and I mean robust security, very robust security. Anyone whose password is admin, please leave now. And of course, we also are return on investment sensitive. It's not cost that's the driver here, it's ROI. We're also interested then, as a consequence of that, in thinking about how we can make things more efficient. Asset efficiency I've mentioned already. Robust security, we talked about new products and new markets. Those are the kinds of things that we're looking for. And towards the end of this presentation, I'll look ahead a little bit into what that might turn out to be. In the introduction, Greg mentioned two economists that made an estimate of the impact of the industrial internet. I'm a little bit worried about that. What does impact mean? And how do you define industrial internet? For example, everyone thinks manufacturing, smart cities, transportation, healthcare when we say industrial. But is retail the industrial internet? Probably not if all you have is point of sale. But if that's connected through your entire supply chain, all the way back to someone just bought something that goes into the ERP system, that in turn generates a request for another shipment from China, and that in turn goes into a virtual logistics system. We're talking industrial. So we don't actually define the boundaries of that. What we're really interested in is what the requirements are and how they are different from those that apply in the consumer world. In any event, these two economists, and I will spell out their names on the next slide because they're responsible for that one too, Evans and Enunciata from GE, they made this top-down estimate, 46% of world GDP, which is around $70 trillion. That's a pretty good chunk of change. As you can see at the bottom, $32 trillion. That's just huge. So you can see again that they did this top down by dividing things up into developing and advanced, and then into different kinds of economy components, breaking it into industrial, non-industrial, though again those boundaries are fuzzy, and then lower down, until we can see what the total is. So I'm very suspicious of this, to be frank. These top-down estimates depend so much on your assumptions that I find them not worthless exactly, because whenever I see a number with $1 trillion in it, I certainly do get excited. But nevertheless, it's not really a good way of thinking about it to my mind. So what they also did, and this I thought was quite a clever way of doing it, was a bottom-up estimate based on GE's lines of business. And you can see the names printed down here. Thank you for them for doing this. What they did was simply assume, don't care how we get there, but let's just imagine that we could get a 1% improvement in fuel cost savings. Today I came to the UK from Paris. I chose not to take the plane. I took the train instead. Circling Heathrow, that's an awful lot of stuff. Imagine if we had better ways of, if we can control connected cars, controlling connected airplanes. Just think how much money we can save in that way. It can be huge. And that's their estimate based solely in GE. And you can read the rest of the numbers here. No reason for me to do that. Sorry about that, my fault. And I'll move on to the next slide. This is what happens when you borrow your brother's phone when your own was stolen on the metro yesterday, just to make sure that we're doing well on timing. In any event, these next couple of slides come from McKinsey & Company, and they did a pretty good look at the trends. This is quite recent, about 6 months, I'd say. And they divided it into 3 groups. The first one is the company level, the next is the market level, and the third is technology and data. So let's take a look at these first 2. The first thing that they point out is that IoT, and industrial IoT in particular, is a business opportunity, not just a technical opportunity. And I'll come back to that idea a little bit later, because if I say our goal is to accelerate the development of the industrial internet, that means connecting to industry, actually talking specifically to the people who are building smart factories, connected cars, and so on and so forth. Given those numbers that we just saw, I think we can agree that yes, indeedy, this is about business, although of course it's often driven by excitement around the technology. This second point, I think, is absolutely key, extremely important if you're thinking about applying this kind of technology to your business. You need disciplined execution across multiple use cases. What that means is building up a product portfolio, trying to figure out how you can make money from this next project, understanding those, prioritizing them, picking one off, and then doing it. And if need be, dropping it quickly if it doesn't work. And of course, taking, if it does work, the results from that and applying that knowledge on the next project. And so it goes. Just doing things in a scattered way across the organization isn't going to work. So instead, you need things like a center of excellence. You need somebody looking at the overall portfolio. You need to take security very seriously and all the way up to the board level, so on and so forth. And I will come back to that on the last slide that I have here, because that concerns connecting multiple vertical sectors together. Again, Sir Tim Berners-Lee wasn't thinking of navigating using his phone, but when you start to think about the things you can do with the internet, well, yes, that's what you can do. And that's happening because we put together two technologies and invented a whole new market. That's really pretty exciting, I think. A third point that they make at the company level is that IoT is enabling more subscription business models. But consumers are resistant. Of course, that doesn't mean that industrial users are resistant. I would prefer, perhaps, to lease my aircraft engine rather than splash out $1 million or so to buy one. That way, the responsibility for maintenance does not fall onto my shoulders, and so it goes. So subscription is an interesting way of reaching business users, although not so much, as I said here, the customers. I live in Southern California, and I'm probably a criminal because I don't have a car. Instead, I use things like Uber and Lyft. Other options are available as a way of getting around, and it's significantly cheaper than having an asset sitting in my garage when I'm in Europe. At the market level, we're seeing some progress, and I'll come back to that a little bit later on as we continue to look at what we're doing so far. We do have Amazon and Google making connections to consumers, and that may change the notion of the resistance to subscription business models as we proceed, but we don't know yet. And then it's very important to understand that China is making huge steps forward. I won't say anything about the president of the US and his current actions. That might slow things down, that seems fairly clear. But in China, AI is extremely strong. Not only do they have very powerful people working on these kinds of things, very smart people, very well-educated people, but they also have masses and masses of data. If you're going to do any kind of machine learning, having a lot of data is the way to go. So that is really important as we proceed. The next group that they talk about is technology and data trends. There are some concerns and conflicts around data access. In Europe in particular, there's a very strong emphasis on privacy, perhaps a little bit less so in the US, but it hardly exists at all by the time you get to China. People there are simply, they don't think about it. The state knows everything, and that's just the way it is, and it's okay. People are happy with that. But we also have different rules about where we store data, who owns it, its usage. GDPR, of course, is a classic example here. If you gather data in Russia, that data must stay in Russia. It's not allowed to store it outside its borders. That's a consequence of having different jurisdictions, different kinds of data sovereignty across the globe. That's going to make it difficult to get the level of reuse that we really need to make these kinds of things work. So that's an issue that we need to be thinking about a little bit as we go forward. Next up, I think this next item here is a very obvious statement. It's just a statement about technology and the fact that technology improves in response to cost pressure. There was a time, I should say, when everybody thought we could put everything into the cloud. And then they thought about that for a while and realized that that was going to be expensive, because if you're bringing huge amounts of data from some device all the way to the cloud just to take a look at a couple of data items, that's just going to bump up your networking costs hugely. And so people started moving things down. The military actually did this in the US about 15 years ago, a little bit less perhaps, where they started to try to centralize decision-making in the Pentagon. And what happened then was that they found they didn't have the local knowledge when you lose connectivity and so on and so forth. And that's why we're currently talking about edge computing, shuffling computing closer to the sensors of the physical plant, and fog computing, which is another way of talking about where you place that computing between the cloud and the sensors and the actuators. Both of these things actually are extremely close. It really depends on your perspective. So we're looking and seeing different architectures coming out as a result of this, so that we can reduce our costs. So far, there have been no major cyber attacks. That's good news, I suppose. I mean, how could it not be good news? But on the other hand, we do need to be sure that people are taking security seriously. So I would be thinking about what might happen there if things went horribly wrong. In Europe, and particularly in the UK, people talk about frankenfoods, so-called genetically modified food, and they get very distressed about it, let's put it that way. That kind of resistance does not exist in the US. If we had a large-scale industrial internet accident, that could change people's attitudes pretty fast. And AI is definitely up and coming. And as I said earlier, China is working very hard in that area. So I see then a number of big picture trends. I borrowed some of this again from McKinsey & Co., but reorganized it slightly just so that we're clear that it's my fault, not theirs. First off, people are reevaluating. People go into IIoT projects and they see something happening and they're happy about it, or perhaps not. And then they ask themselves, wait a minute, why am I here? It's all very well getting excited by the technology, but we need to go back to that first bullet point at the company level, namely that this is a business thing, not a technology thing. So we're seeing a fair bit of that going on. The question is, how do you make money out of this? And that goes to the second bullet here, the business model and monetization. How are we going to do that? How do we make money out of this? There is a large diesel locomotive manufacturer here in Europe who collects 9 million data points from the engine. How many do they use? 3. And I don't mean 3 million, I mean 3. What are we going to do with all that data? Why are we collecting it? What's its value? What can we do with it? Is there some way that we can enhance our business by doing that? So that's another issue that people are thinking about. We also need to think about, I've mentioned risk management already, but changes in business management. Large industrial companies are used to making big bets. The average industrial plant is 19 years old. My phone, stolen in Paris, is probably updating right this minute with some new software. The IT world views updates, that kind of thing, as automatic and rapid. The operational technology, or OT world, factories, connected cars, and so on and so forth, they think longer term because they have to go through safety and compliance checks. And that slows things down. What that means then is that you are reluctant to go through all of that work every couple of days in the way in which my phone updates. So you have to change the way in which management thinks. What that means is making small bets and throwing them away if they don't work, or investing more heavily if they do, rather than the current way of thinking of things, which is, oh, let's see, let's build a double-decker airplane and see if we make money 20 years out from here. That's not going to work. We don't know enough about the industrial internet at the moment to know what we're doing. I mean, we're experimenting, let's be clear. And again, when the URL was invented 30, not 40, my fault, 30 years ago, no one had any idea of the kinds of things that we might be able to do. So that's important. We're also seeing consolidation and reorganization that includes in consortia such as my own. As I said, we joined forces with OpenFog in January. Smaller niche companies with niche technologies are being bought. And also things are being spun off. For example, GE Digital, my understanding, is being spun off from GE, the holding company. You also have questions about talent. How do you find people who know how to build these systems? If we haven't built many of them before, how can we even understand what we don't know? I mean, I know we might need software people, that seems pretty clear. We need hardware people, yeah, imagine. We're going to need people who do analytics, but is that the complete list? Well, what's missing? So we need ways of being able to characterize our systems before we build them, to understand the size and the scope and the shape of the project, and then see if we can understand what talent we need to fill that. And then, of course, we need to go out into the real world and find those people and actually get it done. Interoperability, of course, is important, especially across global supply chains, and security. You've seen this chart before. It's the famous Gartner height curve. Some people are here, some are there, some are somewhere else. But roughly speaking, we have gone past the peak of inflated expectations. That's why I'm saying that people are reevaluating and they're thinking about business instead of technology. But we can, over time, get to the plateau of productivity. I took one of the first computer science degrees in the mid-70s, only now, because we have cheaper computing and cheaper data, is it really coming into its own. I expect to see the same thing happening with the industrial internet. What does the future hold? Well, this is a copy of Sir Tim's proposal. I like in particular vague but exciting. And of course, we also have Yogi Berra. It's tough to make predictions, especially about the future. I agree. But some people are bolder than I am. This includes, and I'll give you the reference towards the end, a joint paper between the World Economic Forum and Accenture. They identify 4 waves. The first wave is all about asset and operational efficiency, using assets better, reducing operating costs, getting greater worker productivity. We know about that. That's where the gains that GE was seeing after publishing in 2012, they were seeing about a 4% improvement in some lines of business by 2016. Not all of them, let's be clear. So it might be maybe 2% across all their lines of business. That's still a fair chunk of change. The next phase, we are already in my view. Lyft, Uber, etc. are examples of this. We're paying per use instead of having the assets sitting around. We're seeing more software-based services and data being monetized, although, as I said earlier, that is an issue. The third wave is focused around outcomes, shifting from selling assets or even services and selling outcomes. I wish to move this mass on this airplane from here to there. I'll pay for that. I don't care how many engines you use, as long as it's safe and as long as you succeed in doing what I asked you to do. That's outcome based, right? It's not buying the asset, it's not leasing the engine, it's not treating it as a service, it's the outcome that you care about. I'd say that we're about 10 years away from something of this order, perhaps a bit less in some industries, more, of course, in others. I don't think that we're there yet, but we're seeing hints of it. And the final one, I have no idea what it means. The autonomous pull economy, that's an interesting phrase. But on the other hand, again, I see some of this already. This is where the user specifies what they want and basically sends it out to a virtual marketplace where it is manufactured in a virtual factory and then goes through virtual logistics to get to my business. So this is why we're talking about autonomous. It's working on its own. And pull, instead of building things and seeing if people buy them, instead we're sensing demand. For automating from one end of the other. I used retail as an example earlier on in this short presentation. And of course, significant resource optimization and waste reduction. These are the authors. I urge you to look it up. Of course, this is being recorded, so we should be able to find that out later. And with that, I thank you very much and hand back to Greg, 1 minute late. Sorry about that. I believe we're having questions at the end, but back to you, Greg. Thank you.
Perfect. Thank you, Stephen. And thank you for the fantastic insights. I love the statement that IoT is a business opportunity and not just a technology one, and that disciplined use cases are the path to value, embracing these projects holistically throughout organizations. Great session. Thank you. So moving on to our second session today, which is entitled How IIoT is Driving Business Value in Manufacturing and Other Industries. Our speaker is Christoph Inowen. He's the VP of Strategy for Siemens MindSphere. So companies are implementing operational IIoT initiatives to achieve cost efficiencies and drive organizations into the value chain. As IIoT-related costs of data collection, storage, and analytics continue to decline, companies are tackling industry challenges. New business models are also being driven from the transparency and insight that IIoT enables. This session is going to cover value of data across the value chain, new revenue streams addressing key industry challenges, product as a service, and real customer use cases will be leveraged throughout. A little bit about Christoph. He's an international business executive who has demonstrated the ability to position technology and cloud SW solutions to influence business outcomes in highly competitive industries and fast-paced environments. He acquired his knowledge through roles in business development, solution creation, product and partner management, as well as strategy over the past 25 years in companies like Schindler, Nokia Networks, and SAP. Currently, Christoph works as a vice president for strategy for Siemens MindSphere, and he's based in Dallas, Texas. Christoph, the floor is yours.
Thank you, Greg. So I'm very honored to be here today to be part of this panel. What I have planned to cover in the next 20 minutes is I wanted to say first a few words about Siemens. Then I wanted to talk briefly about the Siemens MindSphere business. Then I want to talk about some of the change that we're seeing in the industry, and certainly also provide some customer examples, use case scenarios that have actually created real value for our customers. So this is basically what I'm intending to cover in the next 20 minutes or so. With that, let me check and see if I can actually advance the slides here. All right, it should be working now. All right, very good. So most of you are probably familiar with Siemens, but I would still like to say a few words because maybe there is the one or the other facts that you guys didn't actually know about us. So Siemens, who are we? We consider ourselves to be a global powerhouse that's focusing on the areas of electrification, automation, and digitalization. As a company, we're about 378,000 people strong. And Siemens is one of the world's largest producers of energy efficient and resource saving technologies. Now, I think the maybe more surprising fact for you is in digitalization, we have extended our impact constantly over the last decade. Today, actually, we're seen as one of the top 10 software companies in the world. I said, I'm fairly sure that might actually surprise some of you out there. But that's basically who we are. So we take digitalization very close to our hearts. This is a huge focus for us. With that, I'd like to shift gears a little bit and say a few words about the Siemens MindSphere business. So Siemens MindSphere is our open and cloud-based IoT operating system. It is a solution that's available on the AWS as well as the Microsoft Azure, and for the market of China on the Alibaba Cloud environments. So with that, we give our customers a choice and flexibility, and it also allows us to truly scale out globally. As you can see, we operate in more than 200 countries where we also have IoT experts. Speaking about the customers, today we have approximately 1,100 customers on MindSphere. We have seen tremendous growth, especially the last 12 months, which to us gives a good indication that the market is really ramping up. And certainly in the case of Siemens, some of the customers are Siemens-owned businesses. As I'm sure you know, we also have factories. And speaking about those, actually here we connected already 41 plants. We use MindSphere to drive use cases around condition monitoring and predictive analytics and predictive maintenance. We have connected approximately 1.3 million devices and assets. Certainly the exact number is not something we reveal, but as you can imagine, some of the assets have multiple devices attached, and all of those are connected to MindSphere. Something that I'm also very proud of is we have a very large partner ecosystem. Now, I think this is no surprise in the space of industrial IoT. There is no single company that can really do it all by themselves. So to build and form a partner ecosystem is absolutely essential. In our case, as I said, we have over 300 partners in the ecosystem. Partners, they come from the system integrator community. We have small, medium, large system integrators in our network spread across the world. We have signed agreements with ISVs, independent software vendors, and certainly also with technology partners. Then something that I believe helps us also to differentiate is what we call the MACs for short, which stands for MindSphere Application Centers. We have 68 of those spread across the world. We focus in those 68 locations on 20 industries. And here we actually co-develop the solutions with our customers. So we have approximately 1,000 software engineers in those locations, and as I said, they work with our customers on a daily basis to build the solutions that have a significant impact for our customers. Then just a few words about Mendix. Mendix is, for those of you who are not familiar with the company, Mendix is a low-code to no-code app development environment. Siemens acquired that company in 2018, and we have now deeply integrated Mendix and all those capabilities with MindSphere. So that basically means customers, especially on the customer side, the operators of assets, so people, in other words, who may not have deep coding skills, they can use that environment and actually build, with a couple of steps, applications and enable those use cases. So with that, I think we can increase the reach to who actually uses MindSphere and who builds these solutions and applications dramatically. So then I'd like to shift gears a little bit and highlight a statement that was made at the World Economic Forum some time back, actually, but I still like it, and I still think it is absolutely on the spot. So the statement talks about disruption and how to survive disruption and even to thrive in the digital era. This is certainly something also Stephen, by the way, before talked about briefly. So here we have a couple of examples that we're familiar with on the, let's say, the consumer side, but I also in my presentation will then give you some examples on the industrial side. So on the consumer side, we're used nowadays to listen to music that comes from, let's say, Spotify, right? So that's one company that disrupted the way we consume music dramatically, and it's all based with a software-driven approach. Then the taxi industry got disrupted. So nowadays we use, for example, Uber or Lyft, especially here in Dallas, Texas, where I live. The taxi industry is really, really hurting. Fewer people are using the old-fashioned type of service, and they really use Uber because it's a lot more, let's say, customer-friendly, the whole experience, right? And also the hotel industry got disrupted by companies like Airbnb. So disruption is absolutely happening everywhere, and it's also happening in the industrial space. So I just wanted to use this slide to open our eyes and use a little bit to what's actually happening on a daily basis in the world out there. So with that, I want to shift gears again and just say a few words about MindSphere. So this is certainly not going to be a technical presentation. I just want to introduce the capabilities of MindSphere, tell you a bit what it stands for. So MindSphere, as a cloud-based and open IoT operating system, allows you to connect to basically anything, not just Siemens equipment and devices, literally any device from any vendor that's out there. So we collect all the data, we bring it into the platform, and then we use the analytics tools to create insight. Once you have insight, you then want to take action, and action oftentimes is executed in IT landscapes, in ERP systems, et cetera, et cetera. With MindSphere, we give you the ability to basically bridge the OT and the IT world. So you can basically, once you have the insight, trigger actions automatically and directly in other system environments. In terms of the applications that you can build on top of the platform, at this point in time, Siemens, we have a portfolio of about 250 applications. So you get a sense that we're quite advanced in our thinking when it comes to the use cases across many of the industries. So the portfolio of about 250 applications is available today from us. And the way we engage with our customers, this is a slide we created a couple months ago, and it helps us really to talk with our customers about their possible journey. We call it the digital maturity curve. Oftentimes, customers start on the left-hand side. They start by connecting their assets, and they start focusing on services like condition monitoring or asset performance management. And while some of these scenarios can be a little complex, it is still one of the easier use cases to implement. Then as you move more towards the right, things get a little more complex. Now, the next step would be to talk about predictive maintenance or even prescriptive analytics and prescriptive maintenance type of scenarios. Or some of our customers want to optimize the energy consumption. That in itself can be a pretty significant step. And then some of our customers want to implement digital twins. Now, in the case of Siemens, we offer actually 3 different digital twins. The digital twin of the product, which is basically the tools you use when you design a product. And then the digital twin of production, which allows you to simulate a production line before it actually gets assembled and then used to build products. And you can bring all that data from the live line back to the actual simulation tool. With that, you create the true picture of what's happening along the production line. And then we have the digital twin of performance, which basically talks about the products themselves as they're being used in the real world out there. And also here we collect an enormous amount of data, and we can feed that back into the design cycle. So we call this whole experience the closed loop experience. So you bring the data back and you allow the people that design the products to use data from the real world environment to improve the next version of the product. And then things may get even more complex as we talk about artificial intelligence or virtual reality and augmented reality, or even self-optimizing systems. So certainly a customer can jump into this digital maturity curve at any point in time. We're not suggesting that you have to start on the left and then slowly move to the right. You can enter this journey at any point in time. And for that, we have so-called solution packages. So I'm not going to spend a lot of time to go into these details in the interest of time. But I just wanted to give you a feel for how we actually communicate with our customers, how we work with our customers about those opportunities. So then I wanted to shift gears again a bit and talk about some of the customer use cases and examples, and talk a bit about the business impact that those have had for our customers. The first one is actually a Siemens own use case. So Siemens, as you know, we have our own factories, and here we used a factory in Germany. It's actually in Bad Neustadt. We focus in this factory, build actual electric motors. So what have we done here? We have along the production line connected KUKA robots, and there are many of them along this production line. So we collect the data in MindSphere, we analyze the data, and we build an understanding about, let's say, the health status of the robot. That knowledge at the end of the day has helped us to reduce the downtime quite significantly by about 10%. Well, that may not sound like a lot when you actually think about the cost of such a production line and what it means if it stands still for maybe just a couple minutes or a couple hours. This reduction is a significant business value for Siemens. And this is just a starting point for us. So I wanted to share this example to give you a feel for what we're doing ourselves by leveraging MindSphere. The second customer case I'd like to talk about is a company called, from a company called Rital. For those of you who are not familiar with Rital, Rital is a leading global provider of solutions for industrial enclosures. You see a picture of such an enclosure on the left-hand side. These enclosures, they have AC units embedded. And sometimes these AC units, they cause issues, and then it overheats and it causes even bigger issues, right? And so what the Rital has done is they have started AC units to MindSphere. So again, also here we started to collect data, to analyze data, to understand the patterns that lead to certain failure scenarios. And with that, they were able to optimize through predictive algorithms. They were able to optimize the maintenance scenarios, and they significantly improved the schedule planning. For them, it ended up saving them about 30% of the cost for service and maintenance related tasks, which I think is quite significant. The third customer case I'd like to talk about is a company called SKF. SKF is a leading bearing and seal manufacturing company. Was founded in Gothenburg in Sweden in the early 1900s. The company showcased their solution at the Hanover Messe, which took place a couple of weeks ago in Germany. And they showcased their solution at the Siemens MindSphere booth, and it created a tremendous interest. So here is what they have done. They started connecting little vibration sensors next to these ball bearings. And now, personally, I'm not a ball bearing engineer, so I cannot give you all the details of how this works. But depending on the vibration that they can detect, they can determine whether maybe the bearing itself needs more lubrication, or whether there's maybe too much torque in an axle, and there's other conditions. So just by looking at vibration, they were able to truly understand what a condition of the ball bearing may be. And they didn't just stop there, actually. They said, well, now that we have all that information, we could actually change the business model, and we could actually offer ball bearings as a service. Actually, didn't call it like that. They call it rotation as a service. And they even went bolder. They said, actually, and it's mentioned on the right-hand side, with a mine operator in Sweden, they signed a contract that is purely performance-based. So they get paid based on the performance of that mine, which is, in my opinion, a super bold move for the company. But this is how they can differentiate in the marketplace. They're definitely thinking about the future. I think this is what we're going to see more often: very innovative companies that find ways to change the name of the game in the marketplace, in their industry, and with that, find differentiation. The last case I'd like to talk about briefly is the one with Volkswagen. So Siemens were very, very proud that we were together with AWS nominated to build the industrial cloud for Volkswagen. Now, the question is, what is the Volkswagen industrial cloud? Here I actually took the quote straight from the Volkswagen Industrial Cloud webpage. So the industrial cloud will digitalize and connect all the production and logistics data of the Volkswagen Group's 122 manufacturing sites around the globe. This will create an enormous network fed by all the machine, plant, and systems data from every factory and all production and logistics activities. So when you think about this scenario, connecting all the 120 manufacturing sites, bringing in all the logistics related activities, this creates an enormous amount of data. Certainly the data will be used to drive optimization And when you think about Volkswagen, who last year produced about 11 million cars, a optimization of just a couple percent means big money. So we at our end, we're super excited to be part of the journey together with Volkswagen. Now, my last slide, if you'd like to find out a little more about Siemens MindSphere, please visit our webpage. It's as simple as www.mindsphere.io. On there, you'll find a lot of information about MindSphere itself. There's documentation. If you're a developer, if you want to know more about the APIs that we expose, all the services, how we can use MindSphere. We talk about solutions on this page. We talk about customer examples. We talk about the partner ecosystem, and there is also a store where you can get a feel for the applications and solutions that we sell through that environment. So with that, I believe I've used all my time. So I want to thank you very much for listening into the last couple minutes. And with that, I believe I can hand it back over to Greg.
Thank you, Christoph. Thanks for the peek behind the curtain about some of the fascinating use cases you have going on with Siemens and MindSphere. If we move on now to our final session today, it's entitled Integrate Financial Information into Your IIoT Decisions to Ensure Optimal Outcomes. And our speaker is Mr. Anton Vandermoovie, who's a partner at Altavia Consulting LLC. Anton specializes in costing and decision support systems, design and implementation, and has published and spoken widely on these topics. His management accounting philosophy and the Debating the Principles articles led to the global adoption of a set of principles for the use of financial information in internal decision making. He served on the International Federation of Accountants, IFAC task force that wrote a principle-based international good practice guide on costing for internal decision support and co-authored the IMA's managerial costing conceptual framework. Anton currently focuses on the integration of artificial intelligence decision support tools in the IoT landscape. As you consider IoT and AR, and even as you use these new technologies to optimize operations, your CFO will always say, "Show me the money." This session will provide insights into the silent revolution that took place over the last decade in the accounting world and the tools being used today, integrated with MindSphere, to show the CFO the money. Anton, the floor is yours, and please do show us the path to the money. Are you there, Anton? I think you may be on mute.
Sorry, you were right. Thank you, Greg, and good day to everyone. I'm going to try and shed some light on that black box called accounting and what it takes to convince the CFO that an IIoT initiative is worth doing. So we're going to touch on 4 topics. First, the traditional challenges that monetizing factory floor gains and innovations face. Second, I'll be sharing the details of a silent revolution that has occurred in the accounting world, as Greg mentioned, which very few people are aware of and which is crucial to the IoT cause. Third, we will look at the opportunity that the advent of Industry 4.0 and this change in the accounting world provide. And then finally, we'll look at 2 examples of how this new world applies in practice. The challenge with shop floor gains and savings and the benefits of shop floor innovation such as IoT invariably surface when the CFO gets hold of the information and converts it to money or financial gain, because these things always have to be expressed in terms of money. But as the cartoon shows, what typically happens in this scenario is the inverse of the old rabbit out of the hat trick. Namely, initially everybody on the shop floor can see the rabbit, and once the CFO gets hold of the information, the rabbit disappears. The gain, savings, or benefits in financial terms are simply said not to be there. I'm having some trouble with pop-ups here, sorry. In large part, this divide between the shop floor and the top floor can be laid at the door of GAAP, generally accepted accounting principles. This is the way that accounting is done. GAAP serves an entirely different audience, namely external parties like Wall Street and creditors. The principles governing GAAP do not provide information appropriate for internal use, such as the optimization of operations. So, in what way is the revolution that has occurred in the financial and accounting world applicable to the topic that we are looking at today? In 2008, Altavia published a series of articles called The Philosophy of Management Accounting, in which we proposed principles for generating financial information for internal use, such as optimizing operations. Now, I wouldn't recommend that you necessarily read this thing unless you're an insomniac, because it would certainly cure your insomnia problem. Shortly after that publication, the International Federation of Accountants, IFAC, adopted these principles in their official guidance, and in 2012, the Institute of Management Accountants adopted the principles in their Statement of Management Accounting for generating internal information. These principles have since been adopted globally by CIMA in the UK and also the AICPA. And in addition, MESA, the Manufacturing Enterprise Solutions Association, this is a body of 3,000 manufacturers, have adopted the principles and integrated them into their manufacturing metrics guidebook. So it is safe to say that for the first time ever in the history of making stuff and accounting for it, we have accountants and the shop floor agree on a set of principles for generating decision support information for internal use. This is a big deal, and it goes to a point Stephen made in his presentation, namely how to model the IoT world with all of its data. These principles govern how we model the enterprise so that information users can see the wood from the trees. The opportunity here relates to how, based on the principles, companies are now able to integrate operational and financial information. For example, this is an illustration of Altavia's product and service portfolio. We do some fundamental design, control, compliance, and change management work in the gray area at the bottom. On top of that, in the blue area, we design, implement, and support the applications and models that generate management information, the orange boxes. As you can see at the top, these are delivered in large ERP systems or in ProEO, our best-of-breed system, for customers that are looking for more of a sandbox type environment where they can get away from the master data restrictions in the ERP system. The principles enable us to add finance-capable AI on top of the management information. The two AI tools on the left are production and manufacturing recommender systems, and we will look at these in more detail in the final section of this presentation. At the top in the middle, the inductive logic algorithm tells you what your avoidable costs are for any decision. This means there is simply no argument anymore as to the financial benefit of an operational change. On the right, the goal orientation algorithm recommends that the product or service volume and mix that will maximize your profitability. This algorithm can also be used to select the most beneficial process improvement project. With these kinds of AI tools, decision making in your organization becomes more proactive with the explicit objective of optimizing operations. So let's take a closer look at the two manufacturing recommender systems. All of you are familiar with OEE, overall equipment effectiveness. as the gold standard to measure manufacturing productivity in discrete manufacturing environments. The equivalent of OEE for the process industry is something called time in state. Time in state strives to keep manufacturing process running in its optimal operating envelope. The time of state recommender system monitors operating conditions and proposes real-time corrective actions. It is a proactive, preventative approach as opposed to the old school reactive approach to running a manufacturing process. We use the principles to integrate time in state operational information and financial information at a platinum mine, the Royal Bafokeng mine in South Africa. This provides the operator insight into the cost of inaction, that is, if he takes no action to correct the process, as well as informs him of the financial outcomes of actions that he takes. In this instance, we create two models, as we show on the right-hand side of the slide there. The ideal state, which we define with the time in state engineers, and this is typically a stretch target, so it's not necessarily that easy to reach the ideal state on a perpetual basis. And the model for the current state, and this model we feed with a set of real-time measures sourced from the shop floor IoT devices, temperatures, electricity consumption, that sort of thing. We calculate the opportunity cost of running the system outside of its optimal operating envelope every 15 seconds, and we provide that information to the operator. Now, apart from the obvious gains of running the process better, the financial information also opens the door to some other opportunities. For example, reporting the total opportunity cost per shift, per day, per week, or per month. This allows for gaming to drive optimization. For example, put the numbers up on the board so people can see it and different shifts and teams can compete, which also then opens the door to performance-based compensation. The second example entails our best-of-breed solution ProEO integrated with Siemens MindSphere. Similar to the first example, this is also a recommender system for operations that has been integrated with financial information. As you can see on the bottom right of the slide, in this scenario, we are dealing with a vibration on a conveyor which MindSphere picks up. MindSphere detects an anomaly based on a set of parameters such as the vibration, the temperature of the bearing, the electricity consumed by the conveyor, and it then triggers an alarm and sends a signal to ProEO for a courses of action analysis. The user selects the optimum course of action based on the financial analysis, and ProEO sends the option selected back to MindSphere, which then kicks off the corrective action, including scheduling the maintenance order. Benefits of this type of cost-based plant optimization functionality include comparing different maintenance scenarios and highlighting the most cost-effective one, supporting the decision of when to stop production and deploy the maintenance workforce, enabling an effective maintenance schedule, including minimizing negative financial impacts. Because in this calculation, ProEO includes the opportunity cost of lost production, enabling a more efficient overall production schedule and facilitating effective maintenance work management. Now, of course, many shop floor decisions can be optimized in this way. It doesn't just have to be maintenance decisions. And then more for interest's sake, this particular conveyor scenario is on display in the Siemens section of UI Labs, now called MXD, where an example of the 21st century digital factory has been constructed. The facility is located on Goose Island in Chicago. So in conclusion, on the topic of show me the money, showing the CFO the money when it comes to the benefits of IoT was always going to be a challenge under the old way of working. The changes that have occurred in the accounting side of the house and the principles adopted globally for internal decision support and optimizing operations has knocked that wall down. And that's my piece. Greg, back to you.
Great, thank you very much, Anton. It was an interesting piece of the financial aspect. So always great to get the insight on the money side of the house as well as the technology. So thank you for that. I'd like to now ask all the speakers to come off of mute, and we're going to move into our Q&A portion of the virtual conference here today. And just as a reminder, anyone who's listening in today, you can feel free to submit your questions via the Zoom portal. If you look down at the bottom, there's a Q&A portion. There's also a chat column. If it's a question, please put it in the Q&A section. That'll help us to prioritize them and make sure we get them in front of the right folks. You can also feel free to submit questions via the hashtag IIoTROI on Twitter or any of our other social media channels as well. We'll be monitoring there too. So if we jump right in, I've got several questions that have come in. Maybe we'll lead it off. It's kind of an open-ended one. Stephen, what do you think the next big thing is?
Well, if I knew that, I wouldn't tell you. I'd be talking to a venture capitalist. We don't know. We simply do not know. Over time, we will discover things that work and things that don't. And companies pivot all the time. Remember that Nokia, for example, started off selling Wellington boots and then ended up doing mobile phones, and now they're into another business altogether. That is to be expected. It's the way it goes. I do believe that we will see more integration between different verticals. Excuse me. And as we do that, then we'll invent whole new markets. I think that's a key point to understand at this stage of the game. Where we are is what a couple of economists at INSEAD in Paris call blue ocean market. It's pre-competition. We gain more by working together and cooperating to build the market and make it bigger, rather than competing over existing markets and trying to carve out our own little pieces. So your question, what's the next big thing? Is a little bit like and who's going to win the platform wars? Well, everybody. There's lots and lots of space for different platforms. The industrial internet is wide and it's deep, and there's just going to be all sorts of opportunities along the way. But again, if I knew, I wouldn't tell you.
Fair enough. This question came in from, from one of our attendees here. It was Riti. This one's to Christoph. How does Siemens MindSphere enhance data acquisition for better analysis and prediction to optimize overall industrial operation? So it sounds like Riti's looking for some details, Christoph.
Right. Yeah, happy to say a few words about it. So there's a couple aspects that help here. So on one hand, Siemens MindSphere offers a significant number of what we call connectors. Those connectors allow you to basically connect to, let's say, on-prem systems and data that's, let's say, stored there, or to other cloud environments and the data that's stored there, and then also certainly to all the devices and to historian environments, or even to then IT backend systems like ERP systems, CRM systems, and then field management systems. All that stuff is available. So at the end of the day, the trick though is you got to bring all that data, and especially the data that adds value to a use case, into an environment so that you can, across all the data sets that you have, develop a use case that, as it has a business related impact. That certainly is not a trivial task, and just data connectors and collecting data is just half of the story, right? The other half is, and this is what we do, we also use MindSphere to basically calling the normalized data, give it a common meaning, so that you can actually build applications on top of that structure that can be very complex. And we also have a large set of analytics capabilities, from APIs that allow you to do signal validation and things along those lines, to dashboarding capabilities, and to very sophisticated tools that allow you to do complex event processing type tasks, not just in the cloud, but also at the edge. So this is the way we approach it. It's certainly a highly complex environment, but we believe that we have the right portfolio and the right capabilities to help our customers along that journey.
Excellent, thank you. Had another question come in, this one to Anton. If my CFO does not know about the new principle, what can I do to make him aware of them?
No, I mean, that's an important question because the accounting discipline, they always refer back to guidance, right? Official guidance. And this is part of the problem people on the shop floor have, is that you cannot argue with this. But we're in a good place now where all of the major accounting bodies has issued formal guidance on these new principles. And it's globally recognized that this is the way information should be compiled for internal use. So if you, for example, go on Google and search on the IMA's managerial costing framework, you'll get there what is called Statement of Management Accounting for the official guidance on how to do this. So the documents are out there and it's easy to find.
Got it. Thank you. We had a bunch of questions come in quickly here. And just I'll make a general statement. Yes, the slides and the material that you saw today will be made available post-conference. So rest assured that you will be getting that in a link in the following days. So back to some specific questions. Let's see. Have companies that go down the journey of industrial IoT adopted agile deployment and end users and OEMs, and what are any of the lessons learned from that? That came in from Cyril. I'll throw that out to all of you if somebody wants to grab it.
Well, this is Stephen, and as a signatory to the Agile Manifesto, I reckon I'll jump in first. I haven't seen much of that, and I don't think that it's a good idea. As I indicated in the presentation that I gave, the OT, the operational technology people, focus very much firstly on safety, and that requires compliance. And that means going through a whole series of steps to ensure that your system complies with regulatory and legal requirements, and that you're going to be able to deploy this system safely. The idea of throwing it in the air and then testing the bugs out of that just don't appeal to me a whole lot. And if you are, for example, doing a train control system, you can't exactly, try and check that trains don't crash. I mean, you have to do a whole bunch of things like simulation and other techniques to make that happen. Where I do think that Agile makes a big difference is in the boardroom and senior management here in selecting the projects. Again, as I indicated in my presentation, large industrial companies are used to making big bets over decades. And if they are to go into this business, especially in the next decade, they need to be thinking in terms of, let's try and build something. It needs to be safe, needs to be under control, needs to have the right kind of development processes. But if it doesn't work, let's ditch it and move on. Small systems, small test beds. The IIC runs a series of test beds. We have about 26 active at the moment that are testing out things and learning things about technology and learning about new business models. And from that, deciding to move on or not. That very definitely can and should be agile. Thanks.
Perfect. A question coming from Michael says, I did not hear much about the role, objectives, expectations, etc. of the so-called big telecom in all of this. Given that they will be integral to the needed connectivity for IoT and IIoT, do any of you have any general observations or conclusions in the telecom context? It's a good question from Michael.
Yeah, so this is Christoph. Maybe I'll say a few words about this. I mean, I can certainly not speak for the telcos themselves, right? But what I can say is that the telcos, what they offer also in terms of connectivity options, certainly for companies like Siemens and our customers is very critical, super important. Speaking about the options, I mean, not all the devices need to be connected using a fixed line, for example. Some of them can be connected using, let's say, technologies in licensed spectrum environments, such as LTE and in the future 5G. There is other options for low power and wide range type of let's say, connectivity options. There's satellite as an option, etc. So the telcos, in my opinion, play a very, very critical role to offer those, call it data pipes, right? At the end of the day, we need to have very reliable data pipes, and the way they manage those and the way they offer as options for us is super critical. So in my opinion, they play an extremely important role in the ecosystem. Some telcos certainly go up the stack. They offer IoT platforms as well, and they build applications and use cases. Some that take a different role. But for us, in the MindSphere ecosystem, we see the telcos as our partners.
Got it. Very good. Anyone else have a comment on that? Otherwise, I'll move on to another question. Okay, hearing none. Here's a great cultural question from Kitan. In your experience, what are the key challenges beyond technology to implement IIoT solutions within an enterprise? And he gives an example: organizational culture, skill sets, mindsets. And what are your recommendations to create a strong foundation for technology solutions?
So this is Stephen again. I'll go first on that one. What I see is what people generally refer to as IT-OT convergence. If I'm a software person, every piece of hardware I've ever touched turned into blue smoke. If I go into a manufacturing plant, for example, and I start talking about security, I'm thinking about viruses and worms and so on and so forth. The person who's running that factory or that plant is thinking barbed wire and armed guards. We just are not speaking the same language. And then when we start to build the system, I very rarely think about safety. Obviously, I don't control actuators in such a way that it's going to be hurting people, but it's not on the top of my mind. The top of my mind is doing as required by other pieces of software and so on to make this thing do its job. That's completely backwards. Taken together, when you look at security, privacy, reliability, resilience, and so on, we have this whole question around trustworthiness, and the different cultures, languages, and emphases in a given IIoT project is a huge problem. It's huge. A second major area that I mentioned in my presentation is the organizational culture around big bets and small bets, but I've already talked about that a couple of times. I think that's a pretty big thing. In terms of the business, data monetization, that's absolutely key. We have technology for micropayments and all that kind of stuff, but how are we going to make money out of this data? Who owns it? How is it used? How do we work in an environment where, of course, data can be reused? How does that change the way in which we think about things? And so on and so forth. So those would be the top three things that I would bring forward. I'll hand over to others to add theirs.
Now, this is Anton. I would sort of give you the consulting answer on that one, in the sense of these engagements, and Stephen touches on this, the whole aspect of culture. You have to be prepared to really invest in change management. Go through all of the normal change management aspects around changing the way people work, changing the way people use information, changing the way people make decisions.
Excellent. Well, thank you both. Another comment? I don't want to move on if somebody's about to say something. Okay, this must have been a breath. This question from Joan came in. I think this is targeted to you, Anton, but this is, while I understand how the opportunity costs are being driven and used, has anyone seen scenarios where companies are adopting data as a service business opportunities after creating their IIoT?
No, I'm not sure that's a question specifically for me. I understand the opportunity cost side of the question, but I think the question more relates to data as a service. We have some clients where we actually host the application for them. So I guess that would fall into that side of the question as far as data as a service goes. So it's not that common, especially, for example, in the healthcare business, where you get around these things like HIPAA, and people are very reticent to sort of not having their data completely under their control.
I see. Anyone else or have a comment on that one?
Yeah, this is Christoph. I can certainly offer, let's say, my point of view on this subject. So, I would say data as a service, and I believe it was Stephen who had a nice curve there on one of the slides that talks about, the peak of the hype and then the sort of disillusionment and then the plateau of, I think, productivity as it's called. And, so when I think about data as a service, I would say we're in this ramp up phase towards the, let's say the peak of the hype. So we're not yet at a very mature, let's say, environment where, everyone understands the value, everyone understands the business models, et cetera, et cetera. So we're at an earlier stage. At the same time, one model doesn't just fit it all, in my opinion. So I think there is data that's easier to share and monetize. I do expect that some of the data that will be, let's say more shareable is data that governments, for example, can collect and also publish about maybe environmental aspects, et cetera, et cetera. More tricky things have to do with data that belongs to a certain customer. And then the question is always, who truly owns that data? So who's allowed to monetize it? And then, as Anton said, there is challenges with privacy, especially in a healthcare environment. So there's tons of challenges, but there's definitely also a lot of companies that work very actively in this space. And what I do expect is in the next 4 to 5 years to see many more proof points about the business model and the setup overall that we need to adopt to turn this into success. But again, one size doesn't fit it all. It depends on the industry, it depends on the type of data. But there's certainly a good number of companies out there that are ramping up their activities, and we can expect some offerings along those lines in the not so distant future.
Great, thank you. We had a question come in from Reedy. This is following up on your point, Stephen, of high volume of data being collected, but low volumes being used. What are some of the trends that you've seen for enhancing data collection for better monetization of data?
Good question, that one. I haven't really seen great ideas at the business level. I've seen a number of things technological level. For example, we have a test bed that splits the data stream into two, one of which is used for direct and immediate control, and the other is essentially batched up and sent later for analytics and the rest. And that allows you then to be able to look at the, to extract value from that data, information certainly, and then possibly even wisdom by looking at large data sets. The single thing I think that's going on in the business world that's the most interesting is micropayments. But the fact is, people don't like paying for data. They really don't. They don't want to do it. Businesses, I think they would. And there we have other questions about using data and how it is that it is given up. I was just editing one of the a white paper from another one of our test beds earlier today, and an issue that comes up all the time is that the operator of a plant has a contractor build a particular component, and that contractor expects to use the data and isn't wildly enthusiastic about handing it over. I think we're going to see actually some payments back and forth between component suppliers and the users of those components to make that palatable to people. But I'm not seeing any major trend at the moment, except how do I make money out of this data? I got lots of it, but I don't have a lot of money. Help, help. And that's about as far as it goes so far. And obviously, if you do have any great ideas, please do contact me and I'll run off immediately and talk to my favorite venture capitalist.
Great, thank you for that. Christoph, Jerry writes into us, says data silos are an absolute obstacle for successful full spectrum data science initiatives. How does MindSphere change the game, and what does MindSphere use for time series data storage?
Yeah, okay, so this is certainly a bit of a technical question, but I'll try to answer it, call it a high level in the time allowed here. So, there's a couple of aspects that come to mind. So again, on one hand, it's about data collection in terms of storage. So in the MindSphere world, we use AWS S3 as one of the options to store time series data. There's other options out there, but the trick here is absolutely not to treat data in isolation. I was speaking before about the connectors in our MindSphere platform solution environment. This is absolutely critical, so you can bring data from all different sources together. But then what you have to do is, and this is where MindSphere really does a beautiful trick, it is to bring the data into a normalized pattern so that you can really run analytics algorithms on top and leverage patterns and use that data as well to feed the applications. So it's a highly complex environment, but we do approach it with this openness that MindSphere brings. And as I said, it's not just about looking at data in isolation or in a silo. You really have to bring the data together from various sources. As I said, normalize it, bring it into a certain common understanding or meaning, so it can be used for analytics holistically and also to feed applications.
Great, thank you, Christoph. And Jerry, if you need more in depth, I'm quite sure that Christoph or one of the folks on his team would be happy to circle back with you. So thank you for the question. Here's one that came in from John. It says, what's the plan for emerging market IIoT adoption? Incorporation or open source? Anyone have a perspective on what's going on in the earlier stages for some of the emerging areas?
Yeah, so this is Christoph. Maybe I go first with my point of view. So what we're seeing in the so-called emerging markets is that oftentimes these folks, while they may not be the first to do something, once they get their head around something, they really move fast. And this is also what we're seeing in the market, in those so-called emerging markets, that the interest is definitely ramping up significantly. And these guys are very good at building out very meaningful use cases and build the business cases around them. So we're seeing an accelerated pace, while maybe in the more mature markets, as I said, folks have started years ago, and it was a slow kind of progress over a period of time. What we're seeing in emerging markets is definitely a much steeper ramp up. Sure, you can claim the volume is maybe at this point in time lower, but certainly the ramp up and the adoption is pretty significant. And I think it's similar to what we've seen in my old world, the telco business in the cellular phone space, for example. So in places like Africa, oftentimes people don't even have a fixed line phone, and they never actually bought one, right? So what happened is, years ago, cell phones were introduced, but much later, sure, than in, let's say, call it Europe and Northern America and Australia, etc. But the adoption was really super fast. And as I said, it was basically kind of a way for them to leapfrog even certain technology. As if people didn't buy fixed line phones, they went straight to cellular phones, and the adoption was really, really fast. So for me, it's not just, let's say, a question of when you actually enter, but the market and this particular opportunity field. But it's about, well, at the end of the day, how fast can you bring the use case together, understand the business value, its impact, and then execute against that. So we're seeing a lot of good traction and definitely an accelerated pace.
Got it. Thank you. So Vishnu had a question. So would it be better for a product-based startup, and he gives an example of a startup building an electric vehicle or an EVTOL, just to start implementing the IoT technologies for the manufacturing process? I think he's asking us if it's better to go right out of the gate and incorporate, or hold off on it and wait for a later time.
Yeah, so maybe it's Christoph again. So I mean, it's not something I can give a definite answer for, but in my mind, again, these decisions always come down to the actual, let's say, use cases that can be, let's say, imagined, and the business value that those at the end of the day will bring. So I'm fairly sure, and this is what we've seen in many industries out there, let's say smaller companies, startups. They're very, very innovative. They have a great idea, and then the way they actually execute against that idea, oftentimes they use the latest and greatest in terms of technology, and it helps them to be much faster, more nimble, and fulfill their business goals quicker. So, in my opinion, every startup in that field certainly should take a very close look at IoT technology and figure out if it can help them on the business side, and I'm fairly sure it will.
Great, thank you, Christoph. Mike has an interesting question about data. He says, has the subject of data ownership been an issue for your panelists, and how do you address this with clients? Can anyone speak to the ownership side of this?
With great difficulty. We don't really have good ideas on how to do this. And again, the multiple jurisdictions and the fact that our supply chains are long means that it's rather difficult to come to conclusions on that. But I suppose the right thing to do is to go back to first principles and say, what is the value of this to you? Every free exchange places value depending on how the parties view it. I used the example earlier of a component builder being reluctant to pass over data, particularly if they didn't know how it was going to be used, but there's nothing to prevent you from writing an agreement that restricts the use of the data and, of course, compensates you for providing it. That's a perfectly reasonable thing to do. You have to show value to both sides. I recognize that's a very generic answer because the fact is that the situations are different in every place. It's very much a depends or how long is a piece of string kind of thing. But I would always go back to first principles. Look for the value to the interested parties.
Great. Now that sounds like some sound advice. Well, we'll take one more question because I know we're at the bottom of the hour here, and I want to be conscious of everyone's time. So we'll take our last question here from Leon Girard. How will blockchain services enable a data marketplace and trusted Oracle service for IIoT? Does anyone want to offer some perspective and insight on blockchain?
Yeah, it's Christoph. Maybe I go first quickly on this one as well, since it's also a subject I'm working on. So I would say this, blockchain is certainly not the answer for everything, right? I mean, again, there's a big hype out there in the market, but for certain use case scenarios, there may be better alternatives out there, purely from a technical point of view. At the same time, we absolutely see that blockchain can enable some of the use cases very, very nicely. At our end, we're working in this field to, for example, see how we can use blockchain to build smart contract type situations and all other use case scenarios. At the end of the day, we see that blockchain enhances, let's say, the industrial IoT platform environments with new capabilities. And wherever data or information needs to be shared in a way that is based on the trust foundation, and data and information cannot be changed along the chain, then the blockchain certainly as a technology is something we should consider. So we see that these things absolutely complement each other. But again, blockchain, in my opinion, is not always the right answer for all the challenges that maybe customers try to solve.
Great. Well, thank you for that comment. And thank you for everyone for taking the time to join us today. Please stay tuned for other educational webcasts brought to you by IIoT World later this year, focused on topics that range from industrial cybersecurity or how IIoT and artificial intelligence optimize industrial operations. Our next virtual summit is scheduled for July 9th, and it's going to address collaborative innovation. Just as a closing point, there were a tremendous amount of questions that came in today, so thank everyone for in attendance for their participation. If we did not get to your question or your comment, we do have it registered here, and the folks that were speaking will circle back with you after the event. So rest assured, we'll get a response to your questions and inquiries. You can also secure briefings with our analysts or our co-founders during the upcoming events over the next 4 months or so. We have an event in Boston on June 11th and 12th. IoT for metal formers and fabricators is taking place in Cleveland, Ohio, June 24th and 25th. Global IoT Forum is in Chicago, Illinois on July 9th to 10th. And Digital Industry USA will be participating in September 11th and 12th in Louisville, Kentucky. And stay tuned to our website and the rest of our social media platforms as other events become on the radar screen and become booked. Special thanks to our presenters today and for our sponsor, Siemens, for the educational session. Make sure to check out our upcoming events where our analysts will be present around the globe. And if you like what you heard today, drop us a line and let us know. And also make it a point to subscribe to our newsletter, YouTube channels, and follow us on Twitter at IIoT_world. This concludes our program today. Thank you everyone for joining.